Hi y'all, today we're going to talk about heap. A heap is a special kind of binary tree. There are two kinds of heap, the min heap and the max heap. So what is the special property that makes a heap different from the binary tree? So the property is that in a min heap, for every node x in the tree, all of the x's children are going to be larger in value than x. So let's write that one. For every node x, x's children will be larger than x. And what is a max heap? A max heap says that it is a binary tree in which for every node x, x's children will be smaller than x. So this is going to be the basic property which is going to distinguish a heap from a basic binary tree. So let's give an example of a min heap and a max heap. So this is an example of a min heap. In this tree, every node has children that are going to be larger in value than that node. And we have here the max example. The max heap example. So this is an example of a max heap. So in a max heap, every node is going to have children that are going to be smaller in value than that node. So this is a basic idea of what a heap is and what are the two kinds of heaps. Now let's look into the two basic operations we will perform using a heap. Insertion and deletion. So first, we are going to take a look at insertion. So now there are two ways we can insert elements into a heap. Or rather, there are two ways we can create a heap. There is a top-down approach and a bottom-up approach. So in this video, we are going to be looking at the top-down approach. So what steps must we take when using a top-down approach to insert an element into a heap? So the first step is insert the element to the first available space. So after that, we must rearrange the tree if the heap property is not satisfied. So let's see what we mean by this using an example. So in our example, let us assume we are going to be constructing a min heap. Let's say that we have already a heap like this. Let us say that to this heap, we want to insert 1. So what is the first step? We must insert the elements to the first available space. What does this mean? So we can see that this level is full. The next level is also full. There is no place to add any more nodes since it's a binary tree. Then let's come to this level. We have 4 spaces at this level, out of which one is free. So we're going to go from left to right from these 4 spaces and choose the first available space. So this is taken, then go to the next one. this space is available, so we're going to insert 1 here. Now we have finished the first step. Let's go to the second step. We need to check whether the heap property is satisfied. So what is the heap property? The heap property says that if there is a node, then all the children of that node must be larger than that node. So now that we have inserted 1, we check with its parent. Is 1 greater than the parent? If it is greater than the parent, then the heap property is satisfied. So let's see 1 and 3. 1 is not greater than 3. 1 is less than 3. What does this mean? This means that the heap property is not satisfied. That in that case, we must do our rearrange. So since 1 is less than 3, which violates the heap property, we need to swap 1 and 3. So after doing that, we get a heap tree that looks like this. Now we have swapped 1 and 3. Now we go back to 1. We check 1 with its parent. Now the parent has changed to 2. 1 is less than 2. That means 1 violates the heap property. In that case, what must we do? We need to swap with its parent. After doing this, we get a tree which looks like this. This tree now satisfies the heap property. We check 1 with its parent. There is no parent, so 1 has reached the root. So it's going to satisfy the heap property. In other examples, we can also see that 1 will have a parent, but it will be greater than its parent. So it's going to satisfy the heap property, and we can stop our swapping or rearrangement. So this kind of rearrangement where we inserted node goes upwards through the tree is going to be called up heap bubbling. So up heap bubbling. So in a top-down approach, this is how you're going to insert elements into a heap. Now we have to take a look at how we are going to delete elements from a heap. Removing elements from a heap. So when we say we want to remove an element from a heap, we can only remove the root element. So when we talk about deletion, we are basically talking about deleting the root. So this is how deletions happen in heap. We can only delete the root. So let's see how we are going to do this, or what are the steps to take when we are going to do this. So the first is we will remove the root. And what do we replace the root by? We replace the root with the last element. So after we do this, we have to rearrange. Okay, so when must we rearrange? We must rearrange when only the heap property is not satisfied. So let's take a look at this with an example. Let's say we're going to be deleting from a min heap. So let's say this is a min heap we are going to delete from. So when we want to delete from this heap, what do we mean? We are going to delete 1. And what will be the replace replace it with the last element. So in this heap, what is the last element? This level is full, this level is full, this level we traverse from left to right, 4, 5. 5 is going to be our last element. So we will replace 1 with 5. And we will return 1. So now we must check if the heap property is satisfied. So we will go to 5. Now we will check whether 5 is going to be less than its children. So 5 is not less than its children. So what does this mean? This means that the main heap property has been violated. In this case, what must we do? We need to swap 5 with one of its children. But which of its children must we swap with? So if it is a mean heap, we will swap the element with the smaller child. So if it was a max heap, we would have swapped the element with a larger child. So upon swapping, we get a tree that looks like this. Now we will go back to 5. Is 5 lesser than its children? No, 5 is greater than its child. So what will we do? We will swap. Then finally we will get a tree that looks like this. Now we will see, is 5 larger than its children? Yes. Because it doesn't have any children, we have reached the end, so there's nothing left to swap with, so we can stop. So now we have got a heap with the required elements that satisfies the mean property. It is important to note that when we're going for a mean heap, and the property does not satisfy, we will swap the parent with the smaller child. And in a max heap, when we are trying to delete and the heap property is violated, we will swap the parent with the greater child. So this is just something to remember when deleting from heaps. Now as you can see, the element which we have started out with is going downwards through the heap. So this rearrangement is going to be called down heap bubbling. Down heap bubbling. So this is how you insert and delete from the heap, given that the insertions are done with a top-down approach and the deletions are done with a bottom-up approach. So that's all for today. Thank you so much for watching this video and I hope you learned something about the heap. Thank you so much. Annyeong! Eme!